This is Ms. Benson with SanfordFlipMath, and today we are looking at the Algebra 2 textbook, Springboard lesson number 29.2, and we're adding and subtracting rational functions today. So yesterday and today we've played a little bit with working on multiplying and dividing rational functions. Well, we're moving on to our addition and subtraction. Now, the fractions I have up here aren't actually rational numbers, but they're really similar to what we're going to have to do in order to add and subtract our rational functions. Just like we've been drawing a lot of connections between fractions with multiplication and division, we're going to do the same thing here. So first of all, the first thing that we always need, which I'm sure you remember very clearly, is when we add fractions, we have to have a common denominator. Okay, and neither of these here have common denominators, so we have to make that happen. Okay, the way to do that is, what's the smallest number that we have to multiply? Sorry for the interruption, so we'll come back to this. So there was a little announcement there. All right, so we're looking for a common denominator, which means we need to figure out, is there something to multiply, the lowest number that we can multiply by either of these denominators to get something that's common. So I can multiply this by 3. Well, in order to then make this work, I have to multiply the whole fraction by 1, which is the same as multiplying by 3 over 3. Okay, so then this down here, I'm going to erase my lovely common denominator here. All right. I'm going to multiply across like we do with our fractions, and I'm going to get 9 over 12 plus 5 over 12. Well, now that I have my common denominator, I just add my numerators. Okay, so this is like 5 plus 9 over 12. And that gives me 14 over 12. And since we have to simplify, 7 over 6. Okay, so let's do that once more with just another fraction to get some practice. All right, so 2/3 plus 1/8. Well, we can't multiply 3 by anything to get 8, and 8 we can't multiply by anything to get 3. And so the lowest thing that we can multiply is 3 times 8 gives us 24. So we actually have to multiply each of these by the corresponding fractions that we need to get our denominator equal to 24. Okay, so we end up with 8 times 2 is 16 over 24 plus 3 over 24. Add those up. We have 16 plus 3 over 24 equals 19 over 24. Okay, so this is we've gotten some practice with fractions. I hope I've jogged your memory a little bit. So now we're going to look at something a little more messy when we have our rational function. So we're going to follow a lot of the same pattern that we did yesterday, except for we're just going to factor each denominator. We're not going to worry about numerators right away, because we're going to have to do some multiplying potentially, just like we did in the fraction examples to get our least common denominator. Okay, we also have to then do our factoring, find our least common denominator, multiply the numerators by the missing factors. And as soon as you see it, I'm sure that'll click into place a little bit better. And then we have to add or subtract the fractions based on what we've been given. All right, so our first example here is 2 over x minus 2 plus 3 over x squared minus 2x. All right, so we've got our first step of factoring each denominator. Okay, well the first one, x minus 2, is as simple as we can get it. We can't factor it anymore. But this one here, we're going to pull out a factor that's common in each of the terms. Or we're going to say x is in this term and this term. So I'm going to pull out one or factor that out of that expression. Okay, so x times what gives me x squared? Well, that what I'm going to put here. X times x gives me x squared, and x times negative 2 gives me negative 2x. Okay, so that's what I'm going to use to replace this over here. So my lovely rewritten expression is going to be 2 over x minus 2 plus 3 over x times x minus 2. Okay, so our lowest common denominator then is going to be just like we did with the first one when we had to multiply the two denominators, the two numbers in each denominator. We had to multiply them together to get our lowest common denominator. Well, in this case, this denominator has an x minus 2, and this one does too, but this one's missing an x. Okay, so we're going to make that happen by multiplying this fraction over here by x over x. Okay, so we get 2x over x times x minus 2 plus 3 over x times x minus 2. You don't have to have that x in parentheses, it's just how I started to write it. Okay, and now since we have a common denominator, we've got x times x minus 2 and x times x minus 2. We're going to add our numerators together. 2x plus 3 all over x times x minus 2. Okay, now one thing to keep in mind though is that we have to make sure that we restrict our domain just like we did before. Okay, so we're going to take all the values of our denominator and set those equal to 0. So I've got x times x minus 2 equals 0. Well, since I'm taking each piece of this, each factor of this, well, one factor is x, and the other factor is x minus 2. So I'm going to set x equal to 0, which we don't have any solving to do for that, but it is one of the values of x that will give us a denominator of 0. And we're going to set x minus 2 equal to 0, and that gives us x equals 2. So since these are the two values that will make our denominator equal 0, those are the restrictions on our domain. So this little bit here, we have to fix just a little bit, okay, and add in to our solution that x cannot equal 0 or 2. So here is our final answer for that one. All right, so let's move on to one more. All right, so we're going to follow our first step here. We're going to factor each denominator. Okay, so this one's closest, so we'll put this one in the box. We've got x squared minus 16. So x squared goes there, negative 16. Well, we're finding factors of negative 16, which is a times c, and add up to 0. Okay, well, negative 4 and 4 do that, so I'm going to put negative 4x in the box, 4x in the box, and my common factors in the columns and rows are going to be x, negative 4, x, and positive 4. Okay, so that means my factors end up being over here, 1 over x minus 4 and x plus 4. Okay, now I'm going to take this lovely fraction, okay, bring it over here, okay, and I'm going to say we've got my x squared is in the box, x squared, negative 4 is also in the box, so my a times c is negative 4, and I want that to add up to negative 3. Okay, well, what factors of negative 4 add up to negative 3? Well, there's negative 3 or negative 4 and 1. Well, that just happens to work out nicely. So we've got negative 4x that goes in the box and x. Common factors x, negative 4, x, and 1. Okay. So this over here, we're going to rewrite our denominator, or this fraction in general, as 1 over x minus 4 times x plus 1. Okay, so our denominators have something in common here. They've got an x minus 4 in common, but this one's missing an x plus 4, and this one's missing and x plus 1. Okay, well that means that we need to multiply both numerator and denominator of this side by x plus 1 over x plus 1, and this side by x plus 4 over x. Sorry, I flipped that. Rewind. Okay. So since that's what we're missing, we're multiplying this side by x plus 1 over x plus 1, and this one by x plus 4 over x plus 4. Okay, so just to be clear, we're again making a common denominator by multiplying by each of our fractions by 1. So let's rewrite that down at the bottom. So we've got 1 over x minus 4 times x plus 1, and we're going to multiply this one by x plus 4 divided by x plus 4. Okay, x plus 4 divided by x plus 4 is 1. So I'm really not doing anything to I'm not changing the nature of that fraction. So I'm just multiplying it by 1, but I'm making it so that we can add our two fractions together. Okay, so then again I have 1 over x minus 4 times x plus 4. I'm missing x plus 1, so I'm multiplying this by x plus 1. Sorry, it's squeezed over x plus 1. Okay, so this is going to turn out to be here x plus 4 over, and this comes from that multiplying by the x plus 4 times 1. Okay, x plus 4 over x plus 4 times x minus 4 times x plus 1. Okay, and then we are adding it to x plus 1 over x minus 4, this whole lovely denominator here, and we should see as soon as I have it written, or as you might have on your paper, that now all our denominators are completely the same. So now that we have them the same, we can just add those numerators together, just like we did with all sorts of other fractions and like we did with our last example. Okay, so I'm going to write it as x plus 4 plus x plus 1. I'm going to keep these in parentheses though, just to show where they come from is a little different. Okay, but then we're just dividing by x minus 4, x plus 4, and x plus 1. Okay, since we're adding these, I can just drop the parentheses and rewrite it as, put my like terms together to have x plus 4 plus 1 all over, I'm not going to rewrite this denominator, all over all of what we have there, okay? And then just to make sure that we get it nice and cleanly finished, our final answer is going to be 2x plus 5 all over that long and lovely denominator, x minus 4, x plus 4, and x plus 1. Okay, so again, we've done some addition. We've done addition of rational functions. It's very similar to adding fractions together or subtracting fractions from each other, but always go back to the first step is finding a common denominator. So I have one more example. This one's subtraction. So take a minute, pause the video, and try this out for yourself, and then we'll come back and do it. All right, so we've got to follow our first step, okay? And you know what? For those of you paused and said, wait, are we done with that last example? We're going to go back to this last example here, and before we end it, we have to figure out the restrictions on our domain. Okay, so before we get into that next one, we're going to set our denominator equal to 0, just like we've been doing for all of our other rational expressions. Okay, so when we set this equal to 0, this is separate, this is a separate factor, and this is a separate factor. So I'm setting each one of them equal to 0. So I have x minus 4 equals 0, which gives me x equals 4. That is one value that will make my denominator equal to 0, which is one value that I don't want in my domain. X plus 4 equals 0, x equals -4, and then x plus 1 equals 0, x equals -1, which means that the restrictions are on my domain are x cannot equal -1, 4, or -4. Okay? So now, for those of you who paused and went back and started the next one, we're going to go ahead and start this next one and actually go through it. Okay, so first thing we're doing, factoring each denominator. X squared minus 9, we're putting in the box. We've got x squared minus 9. Well, we need factors of a times c, or -9, that will add up to 0. We want our sum to be 0, so -3 and 3 fit the bill pretty quickly. Okay, so I've got -3x here and 3x here. I just paused it and moved the box down so that we could actually factor it. So common factors here are x, -3, x and +3. So this becomes 1 over x plus 3, x minus 3. Okay, and we're subtracting here. Keep that minus sign in the middle. Now I'm going to factor this lovely fraction here, or this lovely denominator, because that's all we're factoring. Okay, so I have my 3x squared minus 9x. Okay, well, what common factors do I have in each of my terms? Well, I've got an x in both of them, so I know I can pull out an x. So let's do that right away, just to see what it looks like. Okay, we got an x. We're pulling out, so what times x gives me 3x squared? Well, 3x does the trick, and what times x gives me -9x? Well, -9. Okay, well, it looks like there's a couple more, or there's another common factor in our 3 and 9. And that, you're absolutely right, there's a 3 that comes out of both of those. So I'm going to pull out the 3. So I'm going to have 3x. So I'm just pulling that out. So what times 3x gives me, I'm going to go back up to my original here. What times 3x gives me 3x squared? Well, just x. And what times 3x gives me 9x, or -9x? Well, I'm just going to leave that 3 in there. So if I redistribute this, I get 3x times x is 3x squared, and 3x times -3 gives me -9x. Okay, that checks out. So these are going to be my factors of my denominator. So I have 3x times x minus 3, and that is underneath a 1. Okay. Now, I need to find my least common denominator. That's the next step here. Well, I've got an x minus 3 over here and an x minus 3 over here. But what I'm missing from this side is an x plus 3 that I need to add in. And over here, I'm missing a 3x. Okay, so just like before, we're multiplying 3x over 3x, or 1 times 1 over x plus 3 times x minus 3. Okay, and then keeping that lovely subtraction sign in the middle, we're multiplying then our other side by 1 over, we've got 1 over 3x times x minus 3 times x plus 3 over x plus 3. Okay, now when we multiply those through, because we just multiply these fractions together, multiply across, we end up with 3x times 1 is 3x over 3x times x plus 3 times x minus 3 minus 1 times x plus 3 is x plus 3 all over 3x, x minus 3, x plus 3. Now, I'm sure you're asking, are my denominators always going to be equal to each other? So can I just write them together all at once? Well, that is an option, but I'm writing it this way just to make sure that when you do your, when you do your fraction multiplication, you get your common denominators. It just builds in an extra check for you. So if you feel confident in what you're doing, it's okay if you don't necessarily show them separate here, okay? But you do want to build in, but this is a built-in check, so it helps you to make sure that you didn't make mistakes. Okay, so since I do have my common denominators, I'm going to add these together. So I have 3x minus, I'm leaving this in parentheses, okay? I know I mentioned that before, but I'm just reminding you. So we've got 3x times x plus 3 times x minus 3. You know, when this is in parentheses, that means I'm distributing my negative to both parts of this. So this is equal to 3x minus x minus 3 over this whole deal, okay? I'm just not rewriting it for the sake of time because I know that you want the video to be done, okay? So we've got 3x minus x minus 3. I'm combining my like terms to get me 2x minus 3. Then I divide by 3x times x plus 3 times x minus 3. And I'm done, okay? So we've got our subtraction done. Let's just take one more second, okay, to restrict our domain, which means we're setting our denominator equal to 0. 3x times x plus 3 times x minus 3. Bring that down. We're setting that equal to 0. Okay, each factor needs to be set equal to 0. Okay, so I'm setting 3x equal to 0. Well, divide both sides by 3, and I have x equals 0. Okay, x plus 3 equals 0, x equals negative 3, and x minus 3 equals 0, x equals positive 3. And you might not need to, you might be able to realize that right away as you're writing it, but I'm just going to keep writing this to emphasize why we're setting each of our factors equal to 0 in the denominator, and why it's important to always do so is because we cannot have our denominator equal to 0. Okay, so this is our SanfordFlipMath so this is our, well, let me box this. This is our final answer for this last example. And this is our SanfordFlipMath for section 29.2, adding and subtracting our rational functions. And we'll see you later. Bye.